Welcome to the world of data center innovation with the iMasons podcast, discovering the people leading our industrial revolution. My name is Romain Tranchant, and today I'm joined by Obongofon Udombat, a data scientist and freelance project manager in the space of AI and green technologies. He currently volunteers for the Google Developers Group, a non-for-profit that supports the training of tech talents at grassroots levels. He also contributes to the iMasons Innovation Committee through the liquid cooling survey and analysis of the results. Obongofon has agreed to talk to us about AI, what it is, what it can do, project he has worked on, and the future of technology. Let's get right into it.
Hello, Romain.
Hi, Obongofon. First of all, thank you very much for coming on the podcast. How are you doing today?
I'm doing real good. Thank you for hosting me.
That is a great pleasure to have you today. A topic that departs a little bit from the typical and traditional data center discussions that we've been having of cooling and power and ESG and so on. It's been something that I've wanted to do for a while. Data centers are powering the servers that then powers AI. AI gives us some results, and you literally sit right at the top of all of this. So before we dive into the topic today, can you give us a bit of an introduction to yourself, what you do with the Google Developers Group, what you've done with iMasons, and also maybe a bit of a flavor for the projects that you've been running?
All right, thank you. So currently, I lead the Google Developer Group in my community, in my city. Google Developer Group is a third-party, a non-profit organization affiliated with Google. And what we do is that we get support from Google to train tech talents in the field of data science, software development, name them, in a very grassroots level. So in the inner cities community in Africa, Nigeria, everywhere, we get young people to come into digital tech space through that support from Google. So currently, I am the lead in my city of Uyo, Akwa Ibom State, Nigeria. And I was opportune to join the iMasons Innovation Committee, where I'm currently leading the liquid cooling survey and the analysis of the results. And then it's been mind-blowing, and I've been able to see what I could call information gap. I could see the role that AI could play in. Very fascinating was my participation in the AI for Greener Data Center Challenge powered by Cool Gradients, who is one of the partners of iMasons. And there we did use reinforcement learning and aspects of AI to be able to train AI models and then get data from data centers to be able to reduce energy bill on cooling systems in data center. So that was where I saw the real life application, real industrial application of generative AI on the data center and the digital infrastructure space. And as a freelance project manager, I'm interested in green tech. So I had freelanced as a project manager for Evergreenias, a PV solar company located in New Jersey, USA, where we've been able to build a resource allocation tool for solar PV facilities across the US. The project is still ongoing, and I have my own what we call custom GPTs I specifically developed for that project, which is hosted on the ChatGPT Enterprise. So that has been my journey, and it's been interesting. It's been interesting seeing the interplay of AI in the digital infrastructure space and green tech energy. So what I am doing is basically using the AI to solve the problem of AI. What do I mean by that? With the advent of AI, there is increase in energy requirement in data center. A single chat GPT prompt requires the 10 times the amount of energy for a Google search. So that is a crazy amount of energy required here. So what AI does using simulation, using reinforcement learning to train AI models that could help to reduce this energy cost in data center. So that is using AI to solve the problem that emanates from the advent of AI.
That's incredible. We seem to have gone full circle. So we used to have data centers using a lot of power. We build AI with those data centers. Now AI is just helping reduce the power consumed by those data centers powering AI. It's absolutely mind blowing. Before we dive into all this, and I really can't wait to hear about it. Can you give us a definition of AI? What is it? What is it to you? And also maybe a way for people to really understand it, get to grasp with what AI is.
Okay, very basically, I would say it is a computer system that is built to perform human-like activities. A computer system starting from hardware and even software. So the hardware part, like robotics, it could perform human-like activities in industries, in facilities, and also in the software aspect, the generative AI that is on the boom right now. So that is the software aspect. It could also perform human-like activities like generating text, images, designs, even writing codes and building software themselves. So in summary, AI is computer system that perform human-like activities.
That's a great way. I've never heard it quite explained that way before. It's Can you then tell us what the difference would be with the traditional compute that we've seen so far? What's the key differences there?
Okay, I'm going to streamline it to my own field, generative AI. And then in the software aspect, before now, we definitely do write codes and then get our software up. But what happens, the difference between AI and the traditional computing and software development is that it's an algorithm that can continue. When once you set it in motion, it can continue on its own. It's automated. It could be automated. So that's the difference. Like one project I was part of called iBrain1, AI is actually part of your team. It could be a project manager, it could be a developer. So while you go to sleep, AI is still working. So that's the difference between the traditional computer we've seen is that it keeps the process automated while you are aware. You don't need to be there. And once you set the algorithm in motion, it continues to work.
So thanks again for this. Not quite ever heard it explained that way, and I really like it. So what are the use cases that you've seen or maybe worked on? Is there maybe things you could show us that you've built for either through your freelance or demos that would sort of embody the definitions you've given us?
Okay, I'm going to start with AI for Greener Data Center Challenge, which we did in partnership with Cool Gradients. It was with my connection from iMasons, I got that privilege to join that program. It lasted for 10 weeks. So it was the use of deep reinforcement learning to optimize power usage in cooling system, right? And I'm going to summarize the process. I will not dig into a lot of technical jargons. So these are the processes. One, historical data such as temperature, power, pump speed, and set point from thousands of sensors within the data center are collected and are used to train and assemble deep neural network. So what I'm saying in summary, this data, temperature, power, pump speed, set points, have been collected over the years. For the ones that we use specifically started from 2016, right? And these data were being collected from a real data center, and then it is used to train and assemble neural network. How is it done? It is done by using the average future efficiencies, the power usage efficiencies, and additional ensemble layer trained on artificial neural networks. And now the models are stress tested by deploying on a live data center. So we put this, like I use a Visual Studio Code. We're going to put this data here, and we continue to train it to be able to determine a maximum level of efficiency that could be achieved. And then the result was that when the machine learning algorithm, what I call the deep learning models or recommendation, is turned on a live data center, a low power usage efficiency is achieved. And when it is turned off, a high power usage efficiency happens. So this consistently achieved 40% reduction in the amount of energy used for cooling. So this was first done by Google. We were not the first to start that. Google did it in 2016, and then the data scientists at Cool Gradients put it up together in partnership with Frontport AI, based at Netherlands. And then, so in summary, when this machine learning algorithm is deployed on a live data center, we saw that energy bill on a cooling system is reduced by 40%. So that is the
That
first application I've been part of.
that, that's an amazing. Let's unpack that a little bit. First of all, so we're talking about 40% energy reduction on the cooling system based on recommendations coming out of a system that typically wouldn't even know what a cooling system is. You just put data in, it sort of learns how it behaves through the analysis of the information, and then starts telling you, this is the set points, this is what you need to do, turn it on, turn it off, change the configuration, and you achieve 40% reduction in energy. My first question to you is, could a human actually achieve those 40% reduction?
I would say certainly no, because the process that is being used is called simulation, and simulation does not use any direct mathematical formula. There is no one mathematical formula on Earth that could be used to achieve that. So the highest humans can go is by applying a particular mathematics or physics principle and get that up. But in simulation, what it does is that where mathematics stops, where our physics stop, it starts from there and then actually continue to, these are thousands, literally thousands of set points, thousands of parameters, which a human can't do that. So it's the machine learning algorithm that could be used to do that. So I have a mathematics background and I know what I'm talking about. There's no how. Yeah, so where our mathematics stop, that is where simulation and reinforcement learning model starts, and it takes it from there. It's not possible by any traditional means.
So if a human can't get to the solution, what does it take? What are the skills that you need to then put the AI, I would say, learning engine to work and to actually give you outputs that are to some extent, valid for the use case you're doing? How do you get there?
Okay, in one word, I would say you need the machine learning skill. Machine learning, statistics, and programming. Yeah. So first, I don't want to underestimate the value of data collection. So this is possible because people got the data in place. The set point, the temperature, the pump speed in a data center had been collected over the years and stored in a database that is accessible by these machine learning systems. So what the machine learning engineers come to do is they take it and with some lines of code, plenty of them anyway, and they will be able to simulate those. So it comes from data collection and then statistics, machine learning, and programming. Those are the skills needed.
Fantastic. I mean, this is great to be able to see, right? So we're now getting in an area where we're unlocking potential that wasn't achievable before. So take us through. You said 10 weeks from the moment you start in the project to the moment it's completed. How long until you saw those 40% results? Does it take the full 10 weeks? Do you get results earlier? What can you take us through the timeline of a project like this?
Okay, yeah. So it was already tested by Google. So it is something that is a principle, is a standard. That is what is going to happen. Google did it on their data center in 2016 and they achieved that. So what a platform like Cool Gradients are doing is that they are mobilizing their data scientists to apply it to their clients, which are data centers that need their service. So they will go there, get specific data that is applicable to that specific data center, and then they are going to recommend that machine learning models on that specific data center, right? So a work might have been done before now collecting the data, specific data for that particular data center has been happening over the years, right? So
Mm.
um, what the engineers, the data scientists at Cool Gradients will do, a platform like Cool Gradients, they're one of the people doing this all around the world, will do is that they will get those data from your data center and they build a specific simulation program that is specific for that data center. So it may not need to take 10 weeks, yeah, because we were learning, right? It was a challenge, it was like a boot camp. So they had to teach us machine learning, they had to teach us programming, what programming language are we using. That is why it took 10 weeks. So I believe in a month or so, Cool Gradients should be able to um, get your data center cooling system optimized. Yes, 4 weeks.
And to be honest, that's an amazing turnaround, especially given that you've had to learn the technology as you were doing the project. So that's one example.
Yeah.
What are the other areas where AI is being used, and maybe different formats of AI or different technologies of AI? Can you take us through maybe a couple more?
Okay. So I would like to talk about this one is the second one is not necessarily directed to the data center. I'm going to summarize that. Then I will get to the last one that is associated with green tech. So the second one is the OpenAI API. You can it's generic. You can use it for different purposes, and then I try to use it for language interpretation. And for example, in Nigeria, some of our local dialects, we do not have technology courses being taught in local dialects, right? So we do not want our language to go into extinction. So what we do is that we are going to take data science, we're going to take software development, take chemistry, physics, biology, medicine, and then we want to be able to train them using our local dialects. So that is the aspect that we could use OpenAI API. So API is already configured algorithm by OpenAI. I think I can share my screen and then I get into the next.
So whilst you're sharing your screen, just for anybody listening that might not know what an API is, basically
Okay,
it's
yeah,
like a direct automated access to a service, right? To a computerized service.
yeah,
So OpenAI, the company that's behind ChatGPT, enables programmers such as yourself to query their service and send information and receive information back in return that has been processed by their own services. Is that right?
absolutely, absolutely. I don't know if my screen has come up. Um, okay, so yeah, so it's as simple as you can just search here and say you can just say OpenAI API. The first is an advert. So the second here, at a click, it's gonna take you here. Start to build. So what do you want to build? So there are different samples here, and then you can choose what you want to do. So it can do text generation, image, vision, audio, text to speech, name them. So I have used the OpenAI API for different use cases like the language interpretation app that could teach natives different subject matter, different tech courses in their local dialects. So that is the second application use case I've tried my hands on. And finally, I'll get into the green tech parts.
Yeah. Just to come back onto this, so at that point, AI just becomes a service to you, and you're just using somebody else's service to build applications on top of it, right?
Of course, absolutely.
No, this is great. So thanks very much for this. These potentially, these has the potential for magnifying and accelerating the use of AI for certain types of applications, right?
Yeah.
Fantastic. So you say you had a third example of use of
Yeah.
AI. Do you want to take us through that one?
Yeah, so I'm gonna go to chatgpt.com and then so on my ChatGPT interface, I'm gonna click on US Solar Visualizer. This is what I tried my hands on. So I've clicked this, and then this is a US Solar Visualizer by me, Obongofon Udombat. What does it do? It assists with logistic optimization and visualization for solar energy tech, right? So these are a sample of questions that could be asked. You could say visualize PV facility distribution in California, summarize panel types in the US PVDP. This is the US PV dashboard, which is built by the US Department of Energy. You can say optimize logistic for solar, a new solar site. So we took data, my team and I, we are served as a project manager from the US PVDP. That is at the US Department of Energy website. We have these databases showing all the solar PV facilities across different states in the US. So it's an open source platform. You only need to acknowledge that you use their data each time you do. That's the what they instructed there. So we took this data, we trained it on the ChatGPT platform. So this is called custom GPTs. You can explore. There are different GPTs built by individuals, built by companies for different use cases, for writing, for productivity, for research. So I came here and I built mine for our team. So I'm gonna give an example here. So if you are living in the state of New Jersey, for example, you could say I want to locate the nearest solar PV farm closest to me. So I will say give a bar graph or a bar chart showing different PV facilities in New Jersey. So it's going to show the distribution. New Jersey, something, I think so. Solar PV. So give a bar chart showing the distribution of solar PV facilities in New Jersey. So let's watch.
So this is actual live. This is not just a demo. This is something that anybody that has access to ChatGPT can go and search for your custom GPT, as you called it earlier, and actually go and use it now.
Yeah. So what it's doing, it says to generate a bar chart, the distribution of solar PV in I will extract. So it's telling you the process it's going through. So if you can see my screen, it is then analyzing. Yeah. So with this, it says first I extract the data from the uploaded file. So before now we have uploaded the USPVDP file. It's a filter for solar PV facilities located in New Jersey. Like I said, there are different states data there, so it had to go to New Jersey, analyze the data, to create the distribution charts. So here you could see the output. I could expand this, and you see, so these are different counties in and the number of facilities, right? So you now look into the city where you live, and you can dive in and in and in. And I will share, for instance, you could continue the interaction.
Mm-hmm.
I live in, let me choose Mercer, and I need 10,000 megawatts of PV facilities. How do I access that easily? Because this is what it does. It helps you with the logistic
Mm-hmm.
easily. How do I access this easily? Understand your requirement. This is total capacity you need. Um, Local zoning regulations. Okay. So it's giving me the step to follow to be able to access this. Utility, evaluate
Wow.
available land, explore scaling options. Okay, okay, okay. And so on and so forth. It even gives suggestion. What are the key incentives available? Can you provide tips for grid integration? And so on and so forth. So this is possible because of the back what we did at the back end. We were able to input data, like we said, different JSON files, spatial data gotten from the US Department of Energy. We fed it into this and we train it, and we are able to have this output. So this is not how far we can go. We can like to go on and on and on. For those in the PV industry, the green tech, solar energy, this could be actually very helpful for your logistic optimization and resource allocation.
So same question as the first example. So what does it take to actually build like a custom GPT like this?
Okay, yeah. Like we started from the ChatGPT API. OpenAI gives us that opportunity to build on this. So it's right here on ChatGPT.
Mm-hmm.
You could go to the settings, and okay, let's go to explore GPTs. Okay, just here, create. So you can create your own. So we could go here and we say create. So it's almost like it's easier than the API aspect, which is programming. This is like a human language, right? So this is natural language processing and NLU, natural language understanding.
Mm-hmm.
So I'll help you build a new GPT. So you just begin to interact, and at the end of the day, you upload files, you upload data, right?
Right.
And there is also a button that makes sure that OpenAI does not use your data for its own training. That is well spelled out. So you do not be afraid that they're gonna steal your data for their own use. It doesn't happen. So when you come into this platform, you continue to say, "This is what I want." You interact. It's even getting better every day. I don't think it was this seamless when I started mine, but I can see the AI is actually helping you to build another AI here. So yeah,
It's a full
so it's
circle
right there.
inception when it comes to AI building new AI. I mean, so thanks very much for taking us through those examples. Those are absolutely amazing for us to understand why there is such a frenzy at the moment trying to build data centers all over the world that actually supports the custom builds of AI training models and inferences and so on, which is exactly what you've been showing us today. Um, before we part ways, I've got a couple more questions for you. So you've shown us three examples. We know there is a lot more out there. but specifically to the world of data centers, where do you think AI should be applied to? What are the things that people should be thinking about when they're thinking about applying AI to maybe their businesses, facilities, or anything like this?
Okay, so beyond cooling, like we did with the AI for Greener Data Center Challenge, in a data center environment, it may be implemented in a general purpose framework. Possible applications could be improving power plants conversion efficiency, reducing semiconductor manufacturing energy and water usage, or helping manufacturing facilities increase their throughputs. So those are different use cases above cooling in a data center environment that generative AI, reinforcement learning, machine learning could be applied specifically. Another application in the data center environment is a predictive maintenance. And I said it starts from the background of data analytics because I come from a mathematics, statistics, and data analytics background, and I understand that data science or data analysis is an AI that had been in existence in some shape and form, not fully formed. So we are able to have generative AI today because we had a strong background in data analysis in the past. So in a live data center environment, when once data had been collected, data about your different facilities, servers, and everything in the data center, if you put that data in a machine learning model to train it, you could be able to use it for predictive maintenance in the future, resource allocation, and smarter energy grids, and even climate change modeling. So, like we did our modeling using simulation for the Greener Data Center Challenge, we can also use it for climate change modeling for data center smarter energy grids. So these are predictive stuff that we could not use a direct mathematics formula to apply it, like I said earlier, but with reinforcement learning and simulation, this could be applied to general maintenance framework in a data center environment.
That's amazing, and a lot of potential left on the table. So hopefully you'll get inquiries to go and solve pretty much every data center problem with an AI engine in the near future. So talking about this, what's next for you? What have you got coming up?
Okay, I plan to explore deeper integrations of generative AI in the digital infrastructure ecosystem as a whole, focusing on scalable solutions for energy efficiency and leveraging AI for long-term sustainability in the entire tech ecosystem. So starting from the digital infrastructure space, like we are doing in iMasons, the liquid cooling survey, we already see some information gap there, which in the following podcast, the education people will come and educate more on how to optimize and get into liquid cooling for data center. So what I'm interested in is integration using already existing platforms like the OpenAI and even the Google's AI platform to be able to integrate it into into a data center environments for sustainability projects and different green tech energy platform, all to be able to achieve sustainability like we were doing with the PV solar PV project.
That's fantastic. I'm pretty sure a lot of our listeners might want to continue that discussion with you. I'm just going to put up your email address in there. Is there any other way that they can maybe reach out to you?
Okay, I'm active on LinkedIn. Obongofon Udombat is the name. You check LinkedIn. You can send me a DM right away. I'm always active most of the times, and then email as
Yeah.
well. Yeah.
even if they don't reach out, I would recommend to everybody to actually go and follow you on LinkedIn. Your posts are always very insightful, and I've got a lot of very, very good content. So that would be one of my recommendations. On that note, Obongofon, thank you very much for coming on the podcast today. It's been an absolute pleasure to listen to all of your experience on the AI front. And I'm pretty sure we'll have you back very, very soon with all the new wave of projects that you're about to start. If you're a listener of the podcast and you wish to either feature on it or actually have further topics that you want to hear about, please reach out to the iMasons innovation team or directly to myself, romain.frunchant@imasons.org. And until then, thanks very much for listening. And OBF, again, thanks very much for coming and explaining the world of AI to us. Take care.
Thank you, Romain. Have a great day ahead. Bye-bye.
Bye.